Good afternoon, everybody. My name's Steve. I'm a Principal Solutions Architect with the serverless team out of Australia and New Zealand. I help run the serverless business in the region, and I'm very glad to be here today. Today we're going to be talking about application integration for platform builders. I'm going to assume that there's a few of you in the room. This is a 300-level session. I'm not going to be diving deep into individual services that I'm going to be talking about and specifically their features. I'm going to assume that you already have some familiarity with all of that stuff. But what we are going to get into is all of the kinds of things that you might need to consider as you build out a serverless integration platform with EventBridge. So let's get started. So I'm assuming that there's a fair number of you in the room that are either on platform teams or working with platform teams and understand that the common goals of platform development teams is fundamentally to accelerate the business and manage the overall complexity involved in running enterprise-level systems. And typically in these cases, you're going to take you have a product mindset around the platforms that you're developing. And that will include like managing things like infrastructure, container orchestration, continuous deployment, monitoring security, and application performance management. But the question is, what do we do about application integration, right? Application integration represents a significant part of our business requirements, right? But connecting individual business components, making sure that those different systems and components are working together seamlessly, and so you can improve efficiency, data accuracy, scalability, and cost savings. And the approaches that we're typically taking here are sort of more a centralized approach where the infrastructure that is helping us with application integration is centrally managed and provided to us as a service. From developers, or there's also alternative approaches where you can take a more decentralized approach where application teams are managing a lot of that infrastructure. And one of the things that we're trying to do potentially with serverless is looking at finding a way to bring these two worlds together, right? While one side of the equation is looking at standardizing and building capability around that common infrastructure, the other half is really looking for more autonomy so they can take control and build the products and the features that they need to build. And ultimately, from an integration perspective, really our main goal is just to get out of the way, right? We don't want application integration teams and platform teams to be the bottleneck in making this connectivity happening. We want to empower teams to be more or operate more autonomously, and as a goal, fundamentally eliminate as much point-to-point integration as possible. This introduces coupling into our environments, which makes change and acceleration and doing all the things that our businesses want to do very difficult. But we also want to make sure that we've got enough auditing and governance in our systems to be able to achieve the things that the platform team set out to do. So what we're going to be doing today is taking a look at how, we're going to take a quick look at some architectural principles of integration, some of the patterns we have, and look at how event bus topologies play a significant part in us helping understand how we can do this, how we can do sort of centralization and bring together the idea of autonomy. I've spoken a couple of years ago, I spoke a lot about, and I've been speaking a lot about, event bus topologies and how they can affect your architecture. And so this is a critical part of making, ultimately, your integrations work more seamlessly. We're going to talk about event design, schemas and versioning are all really important parts of making sure you've got a cohesive event-driven architecture within your applications, and how platform engineering can help you accelerate and help implement stability within your environments and help accelerate the things that your application teams are building. There's obviously operational concerns as well. We need to worry about the reliability of our systems and making sure that message loss isn't something that we incur frequently. And if we do, we need a way for us to be able to recover from those failures. We need to have, obviously, we're working with sensitive data a lot of the time and making sure that we have ways that we can deal with that, and observability. And all of this is going to end up leading us to this idea of building a control plane for event-driven architectures, potentially with, that's going to be supported by EventBridge. Now, from an architectural principle perspective, I like to think about where do these services live, right? We have lots of integration services, some of them you're seeing on the screen here today, that help us achieve different types of integrations. EventBridge primarily I see as something that is going to be helping you communicate and integrate services, integrate between services or bounded context. I'm borrowing from sort of domain-driven design terminology here. But also, EventBridge Pipes is also another feature of EventBridge, but potentially used for different solutions, more geared towards point-to-point type of integrations where we're taking a lot of disparate sources and potentially converting and transforming messages as they flow through that system, as well as SQS and step functions, which help us achieve point-to-point integrations asynchronously, as well as orchestrating our workflows, potentially orchestrating how particular data processing happens, and various other features. And all of these services fundamentally support different types of integration patterns. And these are significant from a perspective of, as architects, as platform developers, we need to start thinking in the terms of patterns and the significance that has on application integration and the services and applications that we build. Now, what I'm going to be focusing on today is the stuff that happens between our services, between our bounded context, and looking at how events and messages flow through our systems using EventBridge. Now, the typical mindset or the typical kind of approach that people take initially when they're thinking about looking at EventBridge as a form of centralized distribution, event distribution, is this model here where we have an essential event bus, where the idea is that we are sending events, all of the events that our applications are sending are actually flowing through that central bus. But we quickly realized that in order to do cross-account event delivery, we actually need to have an event bus in the receiving account in order for those messages to be sent. Now, this has some benefits, which we'll go into, but fundamentally, in order to achieve this, the receiving account needs to give our central event bus the necessary permissions to be able to do that. This doesn't just happen automatically, right? We have got some safeguards and assurances that you can put in place to make sure that that event flow is securely happening. But the point here is once that security has been implemented, we actually manage it. All of those events are flowing through a centrally managed delivery channel, which fundamentally means for you, no networking required. This is all part and parcel of the fabric of the AWS platform. Now, when we're thinking about how we're composing and how we are distributing our applications, a common approach is that many customers take is the idea of having a multi-account strategy where a particular domain lives in that bus, right? And quite often we'll see that has many different reasons for security and cost and all those other things. But what happens if you have multiple domains in a single account? Well, this is where the idea of a domain plays a central and very important part in how you start to architect and think about managing these resources. So the idea is to have a mechanism around how you can identify domain and share those across those service boundaries and make them freely available to everything in your domain. And by doing this, we can get some consistency in how we recognize, identify, and use these domain names or namespaces as a means of managing the resources that we have. We use them in a lot of different places, not just in naming services and resources, but also you might introduce these into some filtering rules and application implementations that you have. And having a consistent approach to doing this is going to be critical to getting some consistency in your environment. And we can look at things like the parameter store as a means to share those, and Amazon Resource Access Manager as a way of sharing that information across the accounts to make them accessible to the rest of the enterprise. Now I'm going to start building up a little bit of a checklist here around the things that we are going to be needing to take into consideration. And so far on the publisher side, we've got an event bus that is centrally managed by our platform teams, and all publishers are sending events to that event bus. And we've got some domains that we've defined centrally that we're sharing across our environment. On the subscriber side, we have a we need an event bus to receive events, and at the same time we make sure that we have those event buses aligned to our domains. Now, a typical event flow looks something like this, right? In our example, our sales domain will publish an event to the essential event bus. The essential event bus needs to define a policy that allows that domain or that service to publish the events to it, right? And we can do that through a resource policy, which I'm going to show you in a minute. Now, once that happens, we've got a rule. Once that that event arrives at in the event bus, we need to have a rule that then submits and sends that message to the recipient's account. And that's quite a typical rule. Fundamentally, the only target here is the other event bus. Now, in the billing domain, we have to define a policy that says that EventBridge has the permissions necessary to send events to the event bus in the billing domain, right? And once that event is received in the billing account, then the application teams can create a rule on its event bus, and then it can use that rule to process the event in any way it needs to. Right. The question now is, who owns the rule, right? Now, a core principle of event-driven architecture and publish-subscribe patterns is the idea of being able to decouple publisher from subscriber. Now, based on this, that really just means that the subscriber controls the rules that it needs or that it wants to define to know what it wants to subscribe to and how it wants to process that event. Which means it has to own the rule on the central event bus, and it needs to own the rule in its billing event bus. Now, if the relationship was inversed, right, this would require the owner of the central event bus to know where to send all of the events, which defeats the purpose of publish-subscribe in the first place, because now you're relying on a single party to know where to distribute everything. So this approach is a much better way. So we've got two types of rules here. We've got our subscription rule, which I've kind of loosely named here, that defines what events are subscribed to and the target destination where that event gets sent. The integration rule is something that's defined by the application teams that determines how that event is processed. So I could be processing that with a Lambda function or an SQS queue, or it could be a state machine. We have 20 or more native integrations that allow you to process events directly off EventBridge. So if the rules are owned by the billing account, how then will the rule be created on the central event bus if billing doesn't own that resource? Well, the way to do this is through resource policies. The resource policies allows us to create policies that give other entities permission, or principals permissions to create resources on things that they don't own. So the first thing that we need to do to make this call chain happen is we need to create an event bus policy that says that I'm allowing sales account to publish to my central event bus. Right? This is an important security feature, so you don't have unauthorized publishers from a domain that hasn't been registered on the central event bus to be able to send events to it. And that event bus policy looks a little bit like this, where we're saying we're going to give it put event permit, we're going to give it, we're going to allow put event actions as long as the events that are being sent come from the sales domain. The next policy that we need to set is we need to allow billing to create and manage the rules on the event bus. This policy looks a little bit like this, where we're saying the principal for this account is the billing account, and it can create and manage rules as long as these conditions are met. So the event source needs to match. You can't create rules with empty filters, for example, and this allows the billing service to define a rule in their own resource stack, which will then get put onto the central event bus. The third piece of the puzzle, as I mentioned before, is I need to allow EventBridge to send events to the event bus in the receiving account. Now, this policy only actually needs to be defined once, so that's pretty handy. But it allows EventBridge to do the cross-account event delivery. And finally, we have the subscription rule. This is defined by the application teams that effectively determine how that event is going to be processed. And that looks a little bit like this. So we now have, on the publisher side, we've added the ability to create, we've added some policies on the subscriber side, as well as on the publisher side, to allow this integration to happen. From a resource composition perspective, we can start to see we're going to start defining a few resources that we need to have in our stack, right? And we're going to build this up as we go along. Right. That was a single bus topology approach. What about multi-bus topology approaches? How is this different? So what you're looking at now is what we were just working on, right? All of the events flowing through a single event bus. Multi-bus topologies look a little bit like this. There is no central bus that anything flows through. The relationships that subscribers have are going to be directly with the subscribers, the publishers of those events. So now, the control of this is more in the hands of application teams, right? Again, looking at more of a decentralized approach to application integration. Now, this is what we were looking at before. The only fundamental difference is, and we don't actually have to do anything fundamentally different, it's just the responsibility of defining these policies is now with the respective domains. Now, why would you use a multi-bus topology? Well, first and foremost, it really puts sort of more control into the hands of application teams. And look, it removes some of the dependencies that your applications have on centralized services. One of the important things that I think this starts to reinforce is the relationship that those publishers have with other parts of the environment. Because all of the subscriptions are now landing on its own event bus, they can now see who's subscribing to their events, which makes management and potentially evolution of events that they're publishing much more easy to manage. So the thing is, how do we get the best of both worlds? And the way that I'm starting to think about this is, around not just resource utilization. As you can see here, we have some constraints on our event buses today that limit the number of events that can be put on a central event bus. So, if you've got a very large domain, then those rule limits may be reached rather quickly. But what about if we think about aligning, having a centralized approach to aligning our domains where we can distribute where rules get created and how events are published? So it's the same kind of concept that we're trying to build with multi-bus topologies, where we have direct relationships with consumers, except we're just replicating logically, I suppose, in a way, an event bus in the central platform account. This allows us to distribute where rules are being placed, as well as having some alignment to the events that are being published and the subscribers subscribing to those events from those particular domains. So if we take this approach, we really don't have to do too much more. All we have to do is start creating domain event buses for each of the domains that we have in our environment. So we're replacing that idea of having one central place for everything to flow through, and we're replacing that with domain-specific event buses. Right, let's talk about event design. So you will have probably seen this definition many times if you've been to previous events. An event fundamentally is a signal that a system state has changed. But a core principle of events is also the fact that they are an immutable object. This is such an important part of, and often overlooked part of event design, because what we're really trying to do here is, we can't change what happened in the past. It's history, right? And if we start thinking about if we have needs to start modifying a particular event for whatever purpose, then we may need to rethink about how we've modeled that event and whether or not it's an event at all. But more importantly, I think it's more of a contract between systems. Right? This contract is something that is established when we're building relationships with the entities in our business. Right? These exist for a reason, and these relationships are reinforced by these events. Now, some of the anti-patterns that I've seen over the years, where we have people thinking about, masquerading events as data transfer objects, right? This is not the intent of an event. Now, quite often the questions come up is how much information should I put into an event? And I guess that's part of the trick, is understanding, the minimal context necessary for consumers of those events to be able to operate on that event autonomously from any other system. There's also some anti-patterns that where people are using events as a means of directing other systems to do something. Again, that is not the intent of an event. And looking at terminologies and categorizing events in the terms of size and complexity is really not also the intention here. We want to get business context. We don't want to refer to events such as fat or skinny or smart or dumb events. They don't tell us anything about the type of event or the type of relationship we want to establish through this means of integration. And as I said before, mutating events is also an anti-pattern. We want to hold true to that idea of immutability. Some of the latest thinking about, about how much information can be transferred or should be transferred in an event has led to some sort of discussion around including pointers in an event, where if the size of the event or the constraints that our transports are putting on your messages, on your events, then having a pointer to somewhere else where that data lives. Now this is difficult because this couples our events to that location on the network. It also means that the teams looking after that data need to ensure that the characteristics of observability are maintained. There's also security access and all of those other things that make this approach rather difficult. So let's have a look at the different types of events that there are. Now, I like these definitions by Martin Fowler, who classified some events as notification events. These are pretty simple events that really don't have a lot of information in them as such, and typically requires other systems who are consuming events to look to query for more information. We also have this idea of an event carried state transfer event, which is actually pretty useful when you're publishing event or representing changes in data as a potential event. Now, one of the challenges here, and one of the how you can start thinking about an event carried state transfer event, is thinking about maybe a DynamoDB stream event type. Now, this is a great event if you're wanting to be reactive inside a domain. And I say this because this is not something that you would share across service boundaries. Because one, it's actually lacking context, right? It doesn't actually tell us anything about the business event that we've just that we're trying to represent. Two, it exposes exposes others to our implementation. It's quite obvious by looking at this event structure that we're utilizing DB, and that sort of breaks the idea of service autonomy. Okay? So there are many other issues with this approach, but I like this from a perspective of you can use this inside a domain, where you might want to represent this by transforming this event using something like event bridge pipes into something that is representative of the domain event that you want to publish across service boundaries. The domain event is the last event that Martin Fowler sort of defines and has been defined by other people such as Vaughan Vernon, and this is really a combination of the two, right? And this is really, this is the event that is modeled as close to our domain as possible. Now, from an event bridge perspective, we can structure our domain events using our event bridge envelope. And there's some significant fields within this event envelope that helps us define context around that event. Source and detail type, in my mind, act like composite keys that uniquely identify the event across your domain. So the source being the domain and the event detail type describing what type of event it is. With the detail actually containing the information that has been modelled as part of that event and includes all of the necessary context that we want to share with others. Now, one of the patterns that we've talked about a lot over the years is this idea of including metadata. And the idea here is really, I think fundamentally has been driven by some of the constraints that Event Bridge envelope has, in the sense that we can't guarantee the uniqueness of the event simply by looking at the ID field in our event envelope, because this changes as an event flows through your system. So including a metadata object inside your event is an approach that people have taken, where they're defining things like item potency ID as a substitute for, or as a means for uniquely identifying the event if there is not enough information in the detail itself to do so. So, and things like managing the version is also not doable and modifiable in this event either. So we need to come up with some other mechanisms for doing that. Which brings us to the next bit, which is around versioning and schemas. Now here is a really good quote that I like from Adam Belmar in his book, Building Event-Driven Microservices. And the key call out here is that implicit data contracts are brittle and susceptible to uncontrolled change, which reinforces the idea that schemas play a significant part in your event-driven architecture. Now, from an AWS perspective, EventBridge supports multiple different types of schemas. We've got a schema registry that includes AWS events. We have hundreds of AWS services that are publishing events through EventBridge that you can use within your own applications for IT automation, for DevOps, for all sorts of things that are going to make managing and dealing, you being reactive to changes in your AWS environment a much easier thing to work with. There's the Discovered Schema Registry. This is a schema registry when you enable schema discovery on your event buses. EventBridge will actually look at the events that are flowing through that event bus and create a schema for you. And it will put them into that registry. Now, this is great for development if you're not really keen on managing your own schemas, but it's really good to get started and allows you then to potentially even merge all of those events, or those event definitions, into your own custom schema registry. And that is, at a production level, probably more thing that you want to be able to do, because that allows you then to have the schemas for all the events that a particular domain is publishing grouped together so subscribers can see what events are being published by that domain. From a platform perspective, it makes absolute sense for you to be putting your schema registries that are aligned to those to the domains in your environment to make them centrally accessible. Now, the thing to do to manage here is to understand that the actual schema and the definition of the event definition is actually something that the application team should own. Right? They're establishing the context around event definition. It's not something that a platform team would be typically responsible for doing. But we want to be able to have those registries accessible to others and providing the application teams with the necessary access to be able to manage the schemas as they evolve. Which brings us to the next bit around versioning. Now, we've already defined the event as being a signal that a system state has changed. What's probably missing from this definition is the last bit, at a particular point in time, right? Now, if we start to think about how this is represented from a schema perspective, if our understanding of the, if our event changes, then so should the the structure of the event should also represent the event at that point in time. So if events are immutable, therefore I need to create a new definition. So how this plays out is like, how you think about versioning events in your organization. Knowing who your subscribers are is super important, because typically events aren't versioned in isolation, right? You're going to be looking at changing events and communicating changes in a collaborative way. You're not going to come into the office one day and go, I'm going to change this to version 2, because if you do that, everyone's going to have a bad day, right? The idea here is to make it have an understanding of what does my domain event look like, right? And this may actually be influenced by other parts or other parts of your environment, where subscribers might be going, hey, can you please provide me with some more context or information around this event? And then you might say, okay, well, let's have a chat and let's see whether or not other subscribers could make use of that information, right? The whole idea here is that it's a collaborative space and it doesn't just happen. So the migration and the evolution of your versions can be done in a controlled way. Now, when we're doing this migrate, or when we're changing events, versioning, Belmar also introduces us to some interesting definitions around how we think about compatibility. Now, the first one here is forward compatibility, right? Where events are produced with a newer version of a schema without necessarily impacting subscribers. Right? And this is quite a popular way of doing things, right? We might just add a field because we know by adding a field to our event, we aren't going to break anything that existing subscribers are doing. An alternative, the other approach is like working around backwards compatibility, right? Where our subscribers are using a newer version of our schema before we're actually publishing that newer version. Now, ideally, the best of both worlds should be true. Like, we want to be able to design our events and the evolution of our events to take advantage of both forward and backwards capabilities. Now, what this means, though, for you and for EventBridge is that you need to have an understanding that EventBridge actually only supports atomic versioning. So when you create or modify an event schema, you will actually get a brand new version of that schema. Now, this actually is not a bad approach, in my opinion, because it forces us to think about how we're going to migrate those changes across the organisation. and relies on explicit data contracts to be published. The semantic versioning approach that's quite often adopted by customers is more sort of like geared around, that compatibility mentality where we want to have forward compatibility within our systems. But it also doesn't provide a forcing mechanism for consumers of older versions of our event to sort of catch up, because we know that we've got some forward compatibility in the events that are being published. But this really relies on the idea of an implicit contract and can be, over time, going to be difficult to manage. It also doesn't really express the actual current state of how our business is thinking about a particular event. Because from a publisher's perspective, they're always going to want to publish the latest version of the event. Sooner or later, you're going to introduce a breaking change, and you're going to be forced to do an atomic versioning upgrade anyway. So, what does this look like? So these are some of the techniques that customers are taking. They're adding a version number to the end of detail type, or we're including a version number inside the metadata. But none of this actually expresses an explicit relationship with the schemas that we've defined. An alternative approach is to look at, how can we integrate this better with the schema registry? We've made the effort to define and publish schemas. Why not assign or align our schema definitions with that particular event? This is much more explicit because it allows us to actually validate that the event came from a particular source. So this is where platform engineering can help us. Now, Ran Eisenberg from CyberArk has talked a lot about how platform engineering can really help us reinforce some of these best practices and accelerate how developers are working within our environments. And from a platform perspective, we want to make sure that the things that we're building around our integration platform help us make sure that we're doing things like publishing the latest version of our schemas and not needing to know how to define metadata, along with a few other things that we may want to make sure that our systems can tolerate, such as having a durable buffer where in the event that our services go down or the endpoints for EventBridge aren't accessible, that we have a way for us to durably recover from that downtime and not have message loss. That is one of the things that makes event-driven architecture significant, is that we can't have gaps in our history, so we need to also think about how we're going to protect it from a publishing perspective. From a schema validation perspective, as I said, we want to be able to make sure that we're publishing the latest events. And we can use the schema registry to do that. Our utilities that we create and potentially share can cache all of these schemas locally, right? We don't have to necessarily go reach out to the cloud and get all that information all the time. If the development teams are already defining the schema, it means they should have access to that schema. So validating these things before they are sent makes perfect sense. You're not relying on the consumer to tell you you've done something wrong, or not hoping that you're coming up with some crazy architectures that tells you that have a server-side validation only to tell you that you haven't published the right event. That doesn't make any sense. You've broken the contract that you have with your subscribers. Also, application developers shouldn't need to know how to deal with metadata. Right? Metadata is an infrastructure level specific consideration. The libraries that you define should take care of this stuff, right? And I could argue that metadata is actually really good from a context perspective, but where we're currently telling customers to put it is probably arguably not in the right place. Because the event data should uniquely represent the domain event that we're modeling in our systems. So if you take a look at this example here, what I mean is like the example on the left is defining a customer-made preferred event in the most, I guess, with the event intent, right? On the other hand, we are now modeling metadata inside our event object, and that doesn't really make sense because now development teams need to know how to manage, how to create that and populate that And that's not necessarily what we want to have done. So how do we get around this? Potentially, here's an example, is we create potential eventing libraries that expose has a means for us to publish events that encapsulates the creation of detail and metadata, and as a result, when we create our put event call, all of that stuff is encapsulated, and developers only need to publish the events that they're modeling. Okay, so how far have we gotten in our list? We now have a schema registry that is being centrally managed, sharing all of our events. There's going to be also significant, as you see later on, around how our control plane can help manage and facilitate the evolution of this. From a resource perspective, again, we're just adding the schema registry and all of the necessary access policies to allow subscribers or publishing domains to be able to manage the evolution of their events that they're publishing. All right, let's have a look at some operational concerns that you want to consider as you evolve your event-driven platform. Now, one of the things that comes up quite frequently, especially in financial services use cases, is sharing sensitive information across domain boundaries. And how much sensitive data should I share across events? Now, I would first of all ask myself, is sharing sensitive data something that you really need to do, right? Have you modeled your domains correctly? What dependencies do other services have on that sensitive information, and why aren't they managing that autonomously? Because as soon as you start sharing sensitive information across domain boundaries, it now then becomes the responsibility of those consuming services to be managing the integrity of that data. And that operationally makes things a little bit harder to manage. Now, if you are looking at ways of sharing information, then obviously we're talking about some level of encryption. And we can do this at an event bridge level by potentially either erasing information or we're encrypting data. And there's a couple of ways that we can do this. Now, recently we've created the AWS encryption SDK, where we can look at information that's coming through, we can install and initialize our client for the library, we can provide the keys necessary to decipher our data, and then encrypt or decrypt the information that we need to be working with. There's a lot of stuff that you need to do there. So I want to introduce you to AWS Power Tools, which is a toolkit that's going to help you simplify and implement some best practices. And we have a lot of different tools available in Power Tools that deal with the operational aspects of building serverlessly, but which include a lot of these, including the data masking utility, which we're going to look at, which effectively provides us an encapsulated or an abstracted implementation of the SDK, the encryption SDK that AWS provides, simplifying its implementation down to potentially just 1 or 2 lines. It also includes the ability to erase information, which the encryption SDK doesn't allow you to do. It only deals with encryption. So here we can see we're still initializing the client, and we're calling an erase method that is a 1-line implementation. And that fundamentally takes any sensitive data that you've defined and removes that information from your event. Similarly, the encryption method is the implementation of the SDK, but again, we've simplified how you call that across in your applications. All right, let's talk about fault tolerance. This is a big part of making sure that you have end-to-end delivery and you safely deliver the events that are that you're distributing across your event-driven architecture. A couple of years ago, we introduced the idea of having dead letter queues for target configurations. Now, by default, EventBridge will retry any potential failed deliveries for up to 24 hours. You might not want to wait 24 hours. You may want to also have some control around how many retries are performed before you send that message onto a dead letter queue. So this is where having a policy defined, a retry policy with a dead letter queue configuration comes into play. And if you capture errors, or if you get messages on that queue, they're really useful for identifying the potential errors that are in your system. So they may be, someone's deleted a resource unintentionally, or there might be some kind of security error that has occurred. But this is really useful for troubleshooting and giving you the ability to replay that message to the respective source. So again, the question is, who owns this resource, right? Who should own the resource? If the subscriber owns the subscription rule and the integration rule, ergo, they should be responsible for defining the dead letter queues. But how many do you need, and where do they get put? Now, I would suggest that one, you align your dead letter queues to a particular domain. Don't have a dead letter queue for each and every target that you define. Have a dead letter queue for a domain so you can capture all those. Also, make sure that you have a dead letter queue for each integration point. So in this case, our first integration point is a subscription rule. Okay? Here, if anything fails, because there's an a bus-to-bus delivery failure, you can then just resend all of those messages directly to the central event bus, and you can send those on to its intended target. And similarly, you'll have a domain-specific dead letter queue on the application side, which then allows you to inspect your particular processing integration that you're processing the event with, and again, either replay or process that message directly against the intended subscriber. So now we've added dead letter queues to both the subscriber side for the subscription role and also the integration role. We're adding some more from a resource composition perspective, we're managing some additional resources here. Now, from an observability perspective, which is also a significant part of what you're going to be doing and operating as a platform team, is looking at some of the characteristics of your event bus and how rules are currently working. So we've introduced some new rule name dimensions that are going to help you, monitor things like invocation attempts, the number of successful invocation attempts, and the number of retry of invocation attempts. Also and this is going to be particularly useful for dealing with things like understanding where retries are occurring and looking at the potential depth of your error message coming onto your queue. We've also introduced this idea of end-to-end latency monitoring. So you can identify bottlenecks and performance issues that potentially aren't necessarily related to how your rules are being processed. Right? And this is particularly useful to understand the overall performance of your integration with EventBridge. So we're going to add some domain-specific metrics to our central event bus, our platform team, and as well as to on the subscriber side to help us understand how our integrations with our applications is failing. So there's a fair bit going on there. And the responsibilities of these resources are sort of clearly aligned to each of the subscribers. So how do we get out of the way? How do we make things easier for application teams to not have to manage this? Because there's still a lot that they need to do. So what about if we move the responsibilities of doing all of the inter-service, inter-account communication over to, and delegate the responsibility of that to the platform teams? We have the ability to then manage all of the domain accounts, manage all the policies, and manage all of the subscription rules. So we've got some control around how events are actually getting to the subscriber's account. And now we have some standardization around how that happens, because the account team is no longer responsible for managing that information, or the application teams. All the application teams now need to do is understand how to define the integration rules that they need to process the events and manage the dead letter queue configurations, as well as some of the metrics potentially. And so we have now this idea of a segregated responsibility where our platform teams are managing all of the domain resources and subscription rules and helping us deal with schemas and versioning evolution. Remember I said that the subscription rule really defines what events a particular subscriber is wanting to subscribe to? Well, this is how this platform can help. From a domain perspective, we need to have the ability to manage domain identifiers, the actual domain event buses, not just in the central account, but also in the subscriber's account. All of the dead letter queues for that integration, making sure that schema registry is available, and having all of these centralized resources managed is going to take the load off our application teams. It's also going to help us with security in the integrity of the event streams that we're creating, because development teams don't need to be in control of how events are getting to their account. Right? This can be fully managed through interfaces that you are providing through your platform by creating APIs that allow you to subscribe and unsubscribe from events. And this allows you to determine where to place subscription rules, on what event bus. You can then control potentially even filters that filter on specific schemas of events that you're also managing. So we have a fully integral event stream that helps us with verifying and managing how events are getting delivered to the respective accounts. And this is a significant part of ensuring consistency in your environment, right? And dealing with other things like resource management. So overall, we're looking at the platform teams controlling the event stream, not necessarily getting involved with how those events are being processed. That's still very much the application team's responsibility. But all they know is that the events that they subscribe to are being delivered to their account. And their only interface with how that happens is by calling the subscribe and unsubscribe interfaces that you're exposing on the platform. And it's also dealing with specific versioning and version upgrades a lot easier, because the platform actually knows what it's dealing with. It knows, because it's created the subscription rules, it knows exactly what versions a particular event is subscribed to, which allows you to actually now start to think about, can I build out a meta database that has all of these connections in it, which really allows you then some insights into how you might even create some documentation around that. David Boyne, who's the author of a tool called Event Catalog, this might be an actual excellent source for something like that, to allow you to visually and dynamically view events and event streams and how they're connected with other parts of your system dynamically. And also, finally, all of these things being helped by building utilities such as Power Tools, for example, that help platform engineering teams do the right thing, and putting some guardrails around how they're integrating and interacting with your platform. And all of this fundamentally allows the idea of having some standardization around how resources are managed, who is managing them, but at the same time providing the development teams the autonomy that they need to make the right decisions around how to process those events. And this is where I think serverless and Event Bridge can play a really big part in establishing that, that platform consistency that is going to help accelerate your businesses and making sure that you're doing the right thing and helping development integration teams get out of the way and making all this fully automated and possible to do. And with that, I want to say thank you very much and look forward to speaking about this in the future. So got some plans for next year. Hopefully someone put some of this into fruition for you. But for now, hopefully this has been helpful in helping you think about how you might want to compose some of your own event flows in your organizations. So thank you very much.